Blink number 5. Modern science isn't so modern. The ancient Ionians got there first, but their work was suppressed for centuries. For most people, modern science has some sort of association with the Enlightenment, or with the likes of Copernicus and Da Vinci, who were themselves products of the 16th century Renaissance. But in fact, modern science has much deeper roots. The Ionians of Greece were its forefathers. Ionia was a region in the eastern Mediterranean, what we might think of now as the eastern Greek islands and the western coast of Turkey. In ancient times, it stood at the crossroads of civilization. Not only was Ionia a center of trade, but the region was also influenced by Egyptians, Babylonians, and other mighty civilizations. Each of these civilizations had its gods, who were thought to reign over the territory. This left the Ionians a little confused. Who were they to worship? The Greek god Zeus or the Babylonian Marduk? The conclusion they came to was startling. They determined that principles of physics and laws of nature governed the world instead. The Ionians started experimenting and so ushered in a scientific revolution. Perhaps most famously, Democritus invented the concept of the atom in around 430 BCE. It's a Greek word that means uncuttable. He argued that when you cut an apple, your knife is actually passing through empty spaces between atoms. Consequently, he determined that every object could be thought of as comprising atoms and empty spaces. Sadly, however, experimental Ionian approaches and learning were suppressed for centuries. We can blame the Greek Pythagoras for this. Pythagoras and his disciples believed that the world, being perfect and divine, obeyed set geometrical laws. All they needed was pure thought and nothing else. Experimentation had no place in this academic mindset. Critically, the greatest philosophers of the classical world, Plato and Aristotle among them, were profoundly influenced by Pythagoras' ideas. In the 5th to 4th centuries BCE, they started to make the argument that experimenting was no different from manual work in the fields. It was therefore work only suitable for slaves. Pure intellectual work should, conversely, be theoretical. When Christianity grew dominant, it also took the Pythagorean notion of a perfect divine world. Consequently, scientific endeavors that might have led to new doctrine-threatening discoveries were suppressed. This censorship cast a long shadow. It took until the 16th century before the scientific method of observation and experimentation was revived. Blink number 6. Light holds a special place in our universe. Even based on what we can see with our eyes and with telescopes, it's clear that the universe is a wondrous and mysterious place. Exploding stars, cosmic dust, comets, and the richness of planetary colors are incredible in their own right. But what's even more amazing is that there's much more about the cosmos that we can explain, but can't see. The classic case is the speed of light. What's incredible is not only its speed, but also the fact that this speed is a constant and nothing can exceed it. Albert Einstein worked out these properties of light in the early 20th century through a series of what he called Gedankenexperimente, German for thought experiments. Here's an example. Imagine you're in a car about to go over a railroad crossing. The train is on the tracks at a right angle to you and is heading for the same crossing. As you approach the crossing, you realize that you will reach it at exactly the same time as the train, so you slow down just in time to avoid the crash. Imagine instead that a friend of yours is on the other side of the railroad crossing from you. He's further down the road you're on and is watching you drive straight at him. Now for the thought experiment. What if both you and the train were traveling close to the speed of light? Your friend will see you thanks to the light reflected off your car. If the speed of light was changeable, the light would reach you at the speed of light plus the speed of the car. The light reflected off the train, which isn't traveling towards you, would only arrive at the speed of light. In other words, your friend would see you reach the crossing before the train. How can your friend and you experience the same event differently? Einstein realized counterintuitive situations like these could only be avoided if the following rules were followed. Firstly, light always travels at the same speed, no matter who's observing it. Secondly, nothing can travel faster than the speed of light. Blink number 7. Voyagers 1 and 2 carry our civilization through space. Ever since Eratosthenes discovered that the Earth was curved, explorers and travelers have been inspired by science to travel to discover new realms. Nothing symbolizes our sense of discovery better than the voyages of the unmanned spacecraft that are traveling through our solar system and out into space. NASA launched Voyagers 1 and 2 into space in September and August 1977, respectively. The two spacecraft were cleverly designed. They are made of millions of parts assembled redundantly. That means that if one part fails, another can fulfill its role. For instance, each has 3 different kinds of computer, and each computer is itself duplicated. Their power sources are intended to last. It's kind of like having a small nuclear power plant on board. Energy is produced by the decay of a pellet of plutonium. Both craft are supplying us with plenty of data, too, including photographs that are sent back to Earth using radio. Linda Morabito of the Voyager team was able to use some of these pictures in 1979 to discover an active volcano on Io, the innermost moon of Jupiter. The Voyager crafts don't just send us signals, they also carry information about the best aspects of humanity. The scientists decided upon this very carefully. They were aware that should extraterrestrial life forms intercept signals from Earth, they would no doubt get very confused indeed. They would most probably pick up the signals from radio and television broadcasts. Their picture of Earth would be a mix of advertisements for cars and detergents, blended with bursts of official messages sent in times of crisis and war. What would they think of us? Now, there's nothing we can do about those signals. They've already been sent. However, the Voyager team decided to attach to each craft a gold-plated copper phonograph with a cartridge and stylus. On the aluminum record sleeves, there were even instructions on how to play the records. The discs were filled with recordings on what NASA thought was unique and interesting about Earth. They included information about the cerebral cortex and limbic systems in our brains, as well as greetings in 60 human languages. There was an hour of music from all cultures around the globe, as well as sounds from nature and modern technologies. It's a pretty broad selection of material. Perhaps the extraterrestrials who find it will admire our achievements, or maybe they just won't understand. At least we can say we tried. You've just listened to our Blinks to Cosmos by Carl Sagan. The key message in these blinks is that the cosmos is a vast entity almost beyond understanding, but we do know it is filled with amazing and wonderful things. Over many centuries, and thanks to much scientific research, we have learned that our Earth is just one spot in the immense cosmos. We now know our place, but astrophysics allows us to explore it bit by bit.